This video is to finish up lesson 9.2, and we'll be looking at the solution to example 5 and the key ideas of the lesson. Alright, in example 5 we have a rectangular garden and we want to find the dimensions of it. If we represent that with a diagram, our length of our garden can be L and the width of the garden can be W. Once we have our variables, we can write equations using the information in the question. Using that the perimeter of the garden is 17 and how to solve for perimeter, we can set up one of our equations. So perimeter is equal to all of the side lengths added together, which is 2 lengths plus 2 widths. Now, if our perimeter is 17, we can say that 17 is equal to 2L plus 2W. That can be our first equation, number 1. Our second equation we can get from the next sentence, which says triple the length is 2.46 meters longer than 5 times the width. So when you set that equation up, you get 3L is equal to 5 times the width plus 2.46 meters longer. And that's going to be equation 2. When we set those up so that they line up, we need to do a little bit of switching around. So I'm going to switch the left side and the right side of the first equation so that I have 2L plus 2W equals 17. Then I'm in the AX plus BY equals C form. For the second equation, I just have to subtract the 5W from both sides to move it to the left side. So I have 3L minus 5W is equal to 2.46. That's step 1. We've lined up our equations. Step 2 is to multiply the equations to get the coefficients in one of the variables to be the same or opposite. So I'm going to just pick the L variable to eliminate, and the lowest common multiple of its coefficients is 6. So the lowest common multiple of 2 and 3 is 6. So I multiply my first equation by 3 and my second equation by 2. That will give me my new equations. So remember to use the distributive property and multiply every term by those numbers. I'm going to get for the first equation 6L plus 6W is equal to 51. For the second equation, 2 times 3L is 6L, 2 times negative 5 is negative 10W, and 2 times 2.46 is 4.92. Okay, so now I can go and subtract my equations because I have the same coefficient, so 6L minus 6L is 0L. 6W minus negative 10W is positive 16W. Careful when you're adding and subtracting integers. And 51 minus 4.92 works out to 46.08. The next thing you need to do is solve for W. So we're going to divide both sides by 16, and W is going to equal 2.88, and that means the width of the garden is 2.88 meters. So now we can go and solve for the length. I'm going to use the first equation that I made, which I used with perimeter, so 17 equals 2L plus 2W, and if my W is equal to 2.88, I can sub that in for W, so 2 times 2.88 in the equation. 2.88 times 2 is 5.76, and then you subtract that from both sides, 5.76. 17 minus 5.76 is 11.24, which is now equal to 2L. Divide both sides by 2, and you get that the length of the rectangle is equal to 5.62 meters. So, as a recap of what we did in this section, we have now learned 3 ways to solve a system of linear equations, which all give us the solution, or the point of intersection, of the lines. We can solve it graphically, or algebraically using the substitution method or the elimination method. Sometimes a table can help you come up with the equations to represent a linear system. To see an example of this, check out example 2 on pages 484 to 485 of the McGraw-Hill-Ryerson Mathematics 10 textbook. And recall that the steps for solving by elimination are to rearrange the equations so that they are in the same form, decide on a variable to eliminate, and you may need to multiply one or both equations by a constant to get their coefficients the same, Then choose whether you need to add or subtract the equations to eliminate a variable. Once you've added or subtracted the equations, solve for the remaining variable. Once you know what one of the variables is equal to, you can use it to solve for the second variable. And check your answers by substituting both variables into the original equations to check that the left side is equal to the right side of the equations.